We have most of a computer sitting here on the bench today, but we're not getting any picture. Whenever we plug everything in the way it should be, nothing's happening. Let's learn what's going on, and as usual, we're going to start by following the electrons. As is tradition, electricity comes from the mains here at the house. This electricity, according to the plan Brian, the homeowner, chose, is primarily generated from renewable sources, solar and wind, but more on that at a different time. Those electrons make their way here to the wall, where I can then plug this plug in and utilize those electrons to do our work. First thing we need to do is diminish the power down to a more reasonable level. The electricity coming out of the wall is 120 volts AC, 60 hertz, 15 to 20 amps. The functional difference between AC and DC currents is that AC allows us to transmit high energy across long distances, which is why the electrons are able to get here from wherever they're generated.
I will explain it as simply as it can be explained. This PVC pipe right now represents a wire. And we understand if you've ever cut a wire apart, that there's copper inside, there's metal inside. These steel rods represent the copper found inside of a regular wire. We understand that the copper is a metal, and that metals have lots of free electrons hanging out. Okay, they have lots of electrons, and not only that, they have a lot of electrons that are ready to go someplace. They're ready to go. But how do we manipulate these electrons? How do we get them to flow one way or the other way? We need to impose a voltage differential on either side of our conductive wire. If we were to connect an 8-volt battery to one side and a 4-volt battery to this side, the electrons would flow that direction because the electrons are trying to reach a state of equilibrium. The flow of electrons is simply called current, and we measure it in amps. Power is the current times the voltage differential. So if we have a 4-volt voltage differential, 8 minus 4, and we have a 40 amp current, then we'd end up with 160 watts of power. Power is literally an expression of energy per second. We can further alter the circuit by adding resistance. Resistance is simply, we're going to put stuff in the way so the current can't flow at 40 amps, it's going to flow at less than 40 amps. Why would we want to do this? Well, some devices can't handle 40 amps, so we don't want to blow it up. It will literally catch on fire.
In order to regulate the power coming through this wire, we need to use a power supply. This is a 1300 watt power supply, meaning that's as much power as it can handle. Its primary functions are to reduce the power to a manageable level and then subsequently route it to the different places it needs to go, because some of these devices, some of these outputs, some of the things on our computer are going to need 3 volts, some are going to need 5 volts, some are going to need 12 volts, and what the power supply is doing is it's making that process simple, so it's sending the right voltages to the right places. First thing we need to do is send power to our computer. Now you may be wondering why I keep calling this the computer. This is the computer's motherboard. It is the main board. Our main friend here is the 18-pin motherboard connector. Here's what the pins do. This is going to send power throughout the board to run all of the miscellaneous tasks the motherboard needs to do to make the computer do its work. Of primary importance to this arrangement is the CPU, the central processing unit. The CPU looks like this and is responsible for the computing. Modern CPUs have tons of differently routed electron pipelines that allow the computer to perform all the calculations it needs to produce the experience you feel of what it feels like to use the computer. I'll give you a few examples. When the computer is trying to find something in memory, it's usually trying to reassemble it from different addresses in memory. The computer is having to reassemble the thing you're looking for, and that requires lots of different addition operations. It's adding different pieces together and trying to find them all so it can aggregate all the pieces into something that you can see. When you zoom in on your screen, there's tons of different multiplication happening so that the computer can display the same thing but just bigger. Those kinds of basic arithmetical operations form the building blocks for every other thing the computer can do, complex or otherwise, including things like HD graphics, Wi-Fi, online play, ray tracing. Let's give power to the CPU in the 12 volt input, which is these 8 pins right here, which match these 8 pins here. Dun, 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 dun. Now that the computer is able to compute, we'd like to be able to see what is happening. For that we need graphics. This is the I/O ports, is the I/O part of this board, the inputs and the outputs.
Hi there, nice to be with you. Happy you could stick around. Like to introduce Legs Larry Smith, drums.
The inputs and outputs that are meant for end user input, meaning when you buy this computer, These are the ports you would use to plug stuff in. USB ports, audio, display port, which is a kind of video, HDMI, which is both combined video and sound, Ethernet, which is internet, some fancy USB standards over here. HDMI stands for High Definition Multimedia Interface and has 19 pins. And those 19 pins are oriented in this connector in this arrangement. Pins 1 through 9 are more or less the video signal we're transmitting. Pins 10 through 19 are pins that control, regulate, and power that transmission. This TV accepts 3 HDMI inputs and allows us to see what the motherboard wants us to see. Okay. Almost ready to go. Almost ready to start. The CPU is responsible and capable of completing millions of calculations every minute. And the energy flowing through the CPU, despite its incredible efficiency, produces heat. It's not a lot of heat, but all those calculations in aggregate produce enough heat to start to cause problems, and ultimately permanently damaging components or melting. This fan will pull hot air away from the CPU out and draw cooler air in, keeping the CPU cool. There we go. Ready for action. There are 2 more things we need to make this computer go. The CMOS battery, this guy right here, this is a 3.3 volt battery that keeps the clock and saves other fundamental properties of the motherboard. Additionally, we require memory. In order for the computer to be able to open programs, edit spreadsheets, run Spotify, browse the internet all at the same time, we need to be able to store elements and information so that you can work on one thing, minimize it, work on something else, and then subsequently come back to the first thing and you haven't lost anything. That's what your RAM's for. Random access memory. Think of it as always there and ready to spring into action. It's ready to run programs. If you need to do more things on your computer, you can add more RAM. The RAM goes in these RAM slots. These are all 8 gigabytes of RAM. I have 4 of them. They're identical. Let's add them in to the motherboard. Nope. All of these things, working in concert, should technically produce computer-esque behavior, viewable to us on the monitor. That being said, when we turn it on, let's do that for everybody's benefit. Turning on the power supply, right? We know we're getting power to the motherboard from this light rail that's that's in the board here. But how do we turn this on? We have no power button. Luckily, I know where the power button connects to, and it connects to these pins down here. Specifically the 3rd and 4th pin in that row. When I connect those 2 pins together, electricity will get to the rest of the board as if I had pressed the power switch. All that being said, when we turn it on, we aren't seeming to get any output. All the right stuff is plugged in in all the right places. Constructurally, this should be working. So let's dig a little deeper. Let's verify that the correct amount of volts are going to the right places. You know, eagle-eyed viewers might notice that there are 4 LEDs on the board here that are attempting to communicate with us. We're getting an orange light with a label that says RAM, and a red light for the CPU, and then a white light for the graphics, and a brief green light for boot, and then it immediately starts over. There's a couple things that we can try. One, different power supply. Maybe the wrong amount of voltage is getting to either the motherboard or the CPU or both. Okay, that's something you can try. I have another power supply. It's a little bit less, it's 1,000 watts, but we're going to swap that out and see if we can make something happen. So this is a graphics card. This is specifically designed for HDMI and DisplayPort output. And we can add, via these connectors, this graphics card to one of these 2 slots. That's what the slots are there for. And by the way, we can add other accessories and peripherals to different ones of these boards and even mess around with it, connecting things that shouldn't be connected, and making new devices that will make this motherboard help us do other kinds of work, and that could be really cool, but that's a different show. So I've got the manual up here on the main monitor. The manual states that the LED indicators will stay on until the problem is resolved, which means because these 4 LEDs are turning on and then subsequently turning off, the problem is resolved. But I don't really know what that means, and there's not really another clear explanation in the manual about what to look for. So because it's not really completing the boot stage of the startup sequence, we should talk about booting. Booting just means the computer is starting. It's called booting because it's related to the word bootstrapping, as in pulling oneself up by their own bootstraps. And in the olden days, in the 70s and the 60s, very early computers, in order to make them go, you'd have to have a bootstrapper, which is basically a small program that helps the computer to go. So I kind of went down this rabbit hole where I was trying to figure out what we were looking at, because this is not actually the manual. This is the result of a Reddit search that I did to try to figure out what the problem might be. And some people are suggesting we need to take the CMOS battery out or short it out for a certain amount of time such that it will reset the fundamental properties of the motherboard. So I'm going to try that real quick. The manual is telling us that those 2 pins right there, the CLRTC pins, if we are going to clear the CMOS data, then we are going to short those pins out for a few seconds. Here are our clear CMOS pins right here. I'm going to short them out with a screwdriver for a few seconds. I've made sure the computer is off. There's no electricity coming to the board except that in the CMOS battery. And what we're doing basically is pulling all the electrons out of the CMOS battery and just running them back through again to kind of reset everything. If I understand correctly. If I don't understand correctly, please correct me. I just call it like I see it. We're just following the electrons, right? Here's the monitor in question. Let's short the power leads, or short the switch leads so we can get some power. Okay, we're on. We're looking at this monitor now. Big fat nothing. Okay, great. Now let's think. This troubleshooting document likewise suggests removing the CMOS battery and shorting out the leads. It does not like cooperating. Okay, we're checking the display back here. Let me turn it back on. Rats. Big fat nothing. Hold please. For the sake of completeness, let's try the 2 things I suggested. Let's start by adding some graphics, some secondary graphics. Which goes here. Okay, graphics powered and in, so let's try again. There's the fans on the graphics card coming on. Boot's working. Hey, something's happening. Shoot, I kind of got the sense it was kind of working a little bit. Maybe. Something's going on with that. It says, the manual says the light will stay on until the situation is resolved. Which tells me that something is wrong. So let's start over. Everything back off. Come on. Just for the sake of argument, because things were kind of working, I'm going to check the other power supply while we're doing this. This is an 850 watt power supply. We have pins. And we need power to the power supply. Naturally. And the same thing, no graphics. Why are we having graphics problems? Graphics card problems. Now RAM problem? The manual now says short circuit the CMOS battery. Well, we've regressed back to the previous behavior. Checks the RAM looks good. Checks CPU, CPU goes off. Checks the graphics. And now we're at boot. Okay. Okay, we're back to the same behavior. Both VGA and boot are both on. And remaining on. That's frustrating because that doesn't help us. That's the same thing. That's the same place we've been. Let's try different graphics. This is a different graphics card of similar vintage. Modern. You know, the here and now. As usual, we're just trying to rule out the possibilities. There we go. RAM's good, CPU's on, graphics, same thing. The port's bad. Let's go back to not graphics card. Let's go back to onboard graphics. Tries to boot and doesn't. Okay, so something's happening during the boot sequence. Okay, I think we've narrowed that down. Something's happening during the boot phase of this whole process. So let's do some research. Well, we've pretty much reached an impasse on this particular video. Have not made any progress, and I don't know exactly what to do. There is no way for me to return this board anymore, and we can try to flashback the BIOS, but let's make that a separate video so I can talk more about the way the BIOS functions. For this video, the lesson is this is the minimum configuration you need to make a computer go. You need a CPU for computing, for the math. You need RAM for memory, active memory. You need power supply for power. You need a motherboard. The motherboard has programming already prepared in it called the BIOS. And that's what we'll talk about when we talk about computers again. I'm going to set this aside for now. If I can perhaps think of a plan, I'll come back. But that'll be the end of this video. So like, subscribe, live the curious life. We'll be back for something else.